Hey everyone, welcome to Electrofun. In today's video, we will see how we can interface digital to analog converter with STM32. Now, a lot of STM previous board doesn't have an internal DAC. So in this video, just to know that I'm not using any external DAC to communicate, I'm just using the internal DAC. There are many external DACs that you can buy off the shelf that gives you I2C capability to communicate. So let us understand what exactly is digital to analog converter. We all know that what is an analog to digital converter, right? We read some value that is changing with respect to time and then convert that to digital form that we can process further with our microprocessor. Now, DAC is opposite of ADC. We have a bunch of finite values in a form of array or something, and then we convert that into analog form or waveform. So let's get started with it. I'll just follow the same process, creating a new project, selecting my board, which is F446RE, giving the name, which is DAC tutorial, finishing, initializing everything on default. Now to initialize DAC, we come to analog, select DAC. Now what basically this means is there are two channels that we can use. Now out to is nothing but PA5, and by default PA5 is connected to an LED on my Nucleo board. I think everyone will have the same setup as over here what I have. So you can either use out one, which will initialize PA4. If I do that, it will initialize PA4, but I'll use PA5 because it has an LED. So if you are trying to create a waveform which goes from 0 to high and then high to 0, you will just observe that. And I think that is all. We don't need to do any changes. We need to just make sure the buffer is enabled. We'll save this setting. We'll generate the code. Now we'll come to the DAC file, see what functions do we have over here on the outline and what do we need to use. We'll use the DAC start and we'll use the set value over here. So let's use the DAC start first. It takes two parameters, the handle type def and the channel. So just to make it a little more interactive, what I'll do is I'll just define a variable over here as DAC value, and then coming over here I'll just initialize that. This is my handle type over here, HDAC, and then it takes another parameter as the channel, which is DAC channel underscore 2, and we'll use the set value. Now what this basically does is it sets the value, whatever analog value you want to set. As you see, it takes 4 parameters. Type def and channel is fine. Data is whatever data you define. But alignment is something I would like to explain a little bit. So this argument is nothing but defined over here as the setup. We'll be using a 12-bit setup, and then we want the data to be aligned on the right side. So it's just there's a resistor where there's a right side, there's a left side. So when you go on to the data sheet and when you look at that resistor, this is a better choice to do that, because when I look at the oscilloscope, I see something that makes sense to me. So I'll come over here. Now just to make it a little more interactive, what I'll do is I will create a waveform over here. Now since I'm using a 12-bit value, the maximum value will be 4096. I'll just go from 0 to 4095, and then I will increment that in a for loop, and then I will paste that and set it. So it's DAC, then it's channel 2, then define the alignment, which I'll copy from here, 12-bit right, and then the data. Then I'll compile this. Okay, so we don't have any error. I'll just run this. I don't need to change anything over here. I'll open my oscilloscope. Okay, so we have some. I will run that. Will decrease the time frame, increase the voltage, make it 2 volts. So as you can see, and then I'll put a trigger over here. As you can see, we have a triangular wave as per what we have designed. So it goes from 0 to 4095 and then it starts with 0 again. So let's just do a little bit more over here. I'll copy this and then it will be 4095 will be greater than 0, and then I will decrement this, compile this. So now basically what it will do is it will go from 0 to 4095 and then come back to 0, and it will give me a better triangular waveform. So as you see that I'm not going more into the frequency over here, I'm just showing you how to generate a proper analog waveform using the internal DAC. Reduce the time scale. So this is exactly what we want to expect. I am on around 3 volts over here and it's running on 3.3 volts. So that is what I expect, a little bit less than 3.3 volts. It goes from 0 to 4095 maximum and then it comes back to 0 again and it repeats itself into an infinite loop. So I think that is all I wanted to explain about DAC. I hope this is clear so far. If you have any doubts, you can ask me in the comment section below. I will try to get all of them. Meanwhile, take care. See you. Thank you.